They say we know the surface of the moon better than the bottom of our oceans. But here's an even bigger shocker. There is a hidden eighth continent on Earth that many of us only officially recognized in 2017. If that doesn't grab your attention, picture this. A massive landmass roughly 5 million square kilometers in size, with about 95% of it submerged beneath the waves. It's out there, quietly lurking in the southern hemisphere, and it goes by the name Te Reu a Maui, or Zealandia. How in the world did we miss something that immense for so long? And why is nobody screaming about it on every street corner? Today we are diving into the submerged depths of this extraordinary newcomer to the continental lineup, to unravel the story behind its mysterious past, its astonishing geology, and what it might tell us about Earth's future. In this episode, we will explore its formation and how it cracked off from the legendary Gondwana supercontinent, examine the tectonic turmoil that shaped it, and ask the million-dollar question: what does the existence of this watery continent mean for our understanding of planetary processes? Buckle up, dear listeners, because we're about to embark on a journey like no other. And by the end, you may just find yourself craving a snorkel and wetsuit, desperate to see where all those submerged wonders lie. Before we dig deeper into Zealandia's watery labyrinth, let's step back and celebrate the awe-inspiring realization that our planet is far from static. For centuries, we have been taught our world was carved into 7 mighty continents: Africa, Antarctica, Asia, Australia, Europe, North America, and South America. The idea of a missing piece of the puzzle must have seemed like fanciful fiction until the actual evidence came rolling in. Some scientists whispered about this possibility for over 150 years, but not until the combined power of satellite mapping technology and advanced marine geologic research did the picture become crystal clear. In the eyes of those who discovered it, Zealandia is not just a curiosity or a footnote in Earth's geological register. It is a full-fledged continent, albeit one that is mostly hidden from direct human gaze. This is not some trivial islet out in the middle of nowhere, either. Quite the contrary, it is brimming with scientific riddles about how continents rise and fall, how plate boundaries shift violently over time, and how the entire jigsaw puzzle of our planet has more intricacies than we ever dared imagine. Today, we will unravel these riddles one by one, revealing how this sunken landmass fits into the bigger geologic tapestry and why it matters now more than ever. Where did this elusive behemoth come from, you might wonder? To answer that, we have to journey back millions upon millions of years, when the supercontinent called Gondwana ruled much of the southern hemisphere. Picture lush forests, towering mountain chains, and all manner of strange and ancient life forms roaming about. Zealandia was there too, tucked along the margins of Gondwana. But around 85 to 60 million years ago, again, spelled out in words so we do not lose the gravity of that vast timescale, things started to fracture. Tectonic forces, those relentless engines beneath our very feet, pulled at the edges of Gondwana bit by bit. Eventually, the landmass that would become Zealandia broke free. Over the next tens of millions of years, the region underwent epic changes. The Earth's crust stretched thin in places. Huge swaths of land sank beneath ancient ocean waters, and what had once been a broader landmass was drastically whittled down. By around 25 million years ago, Zealandia was so deeply submerged that only slivers poked through the surface. Yet even those slivers, namely modern-day New Zealand and New Caledonia, turned out to shelter some of our planet's most astonishing life forms and uniquely beautiful landscapes. There is something mesmerizing about a place that has truly weathered the test of time. One of the most remarkable aspects of Zealandia is that it is the youngest, smallest, and thinnest of Earth's continents. Now, you might ask what exactly qualifies a region to earn that lofty title. After all, we have archipelagos, island chains, and microcontinents dotting the oceans in various forms. The key is that continents are not just big lumps of rock. They are distinct tectonic blocks that are thicker and generally lighter than the plates comprising the deep ocean floor. Zealandia fits that description. Though it is thinner than the other continents, it is still composed of continental crust, rather than the dense basaltic crust that underlies most of the seabed. So, despite being mostly drowned, it maintains that distinctive compositional identity that sets continents apart. This leads us to a fascinating conundrum. How do we reconcile that Zealandia is effectively 95% underwater while still being a legitimate continent? The reason traces back to geology. Submarine continental shelves can be wide or narrow, and in the case of Zealandia, we witness extremely broad submarine platforms hosting only small pockets of land above sea level. That unorthodox arrangement is precisely why it escaped classification for so many decades. Naturally, to truly understand how this continent came to be, we need to appreciate the dramatic role of plate tectonics. In particular, Zealandia sits astride the boundary between the Pacific and Australian tectonic plates, and that boundary is not a peaceful place. Over countless eons, the jostling of these colossal plates has spawned earthquakes, ignited volcanic activity, and shaped the area in ways that can literally move mountains or bury them beneath the ocean. Everywhere you look, hidden clues are etched into the undersea geological record, from layers of sediment that used to sit on land to fossil evidence hinting at ancient ecosystems not of this watery realm. This trove of knowledge comes from methods such as drilling into the seabed and retrieving core samples, analyzing chemical signatures, and employing seismic imaging to map what lies beneath the waves. The more we learn, the clearer it becomes that comprehending Zealandia is about far more than labeling another landmass. It is about decoding the story of how Earth is constantly reinventing herself, shifting her tectonic puzzle pieces in surprising ways. We are just warming up, so get ready for even bigger revelations. Zealandia is not merely a sunken anomaly. It is a geological tapestry woven from a host of ancient mysteries. Fossils of creatures that once roamed the surface are discovered in underwater mountain ranges. Huge belts of extinct volcanoes stretch across the submerged plateau, leaving us to guess at why they formed in the first place. Scientists scratch their heads. What caused the break from the southern supercontinent? And why did certain regions of the crust become so thin that they sank? The answers, tantalizingly, remain half-buried. But these unknowns are precisely why Zealandia is more than just a historical footnote. As we probe its layers, we expose a record of environmental shifts, mass extinction events, climate changes, oceanic current developments that shape not only this region, but reverberated across the globe. That is what makes the study of Zealandia so vital. It holds up a mirror to Earth's past, reminding us that the planet's climate and ecosystems have always been dynamic, and that we ignore tectonic transformations at our peril. If you are as intrigued as I am so far, go ahead and give this video a like. It might seem like a small gesture, but it tells us you want to keep exploring these hidden frontiers, and it keeps our channel alive so we can dive into even more jaw-dropping stories. By now, you are probably wondering, how exactly did we confirm the existence of Zealandia as this genuine continent? The tale is rooted in patient scientific detective work, powered by an international community of geologists, paleontologists, oceanographers, and more. Data from satellites pinpointed subtle variations in the gravitational field, which hinted at a unified block of continental crust lying beneath the water's surface. Then came the seafloor mapping, revealing the underwater topography that linked New Zealand and New Caledonia in a way that could not be dismissed as mere chance. And through decades of drilling expeditions and dredging, scientists kept turning up more and more evidence, from the types of rock unique to continental crust to ancient fossils that aligned with those found on the fringes of Gondwana. The final piece of the puzzle clicked into place in the early 21st century as high-resolution bathymetry and geological correlation closed the loop, demonstrating beyond any doubt that this was not a mere microcontinent or a random cluster of submerged fragments. This was the real deal, the hidden sibling in Earth's family of continents, just waiting to be recognized by humankind. Interestingly, the presence of such an expansive submerged continent challenges some of our assumptions about how continental crust forms and evolves. Generally, we think of continents as robust, buoyant landmasses standing guard against the relentless ocean, but Zealandia defies that neat categorization. Owing to its history of tectonic stretching, parts of it ended up dangerously thin, enough for vast areas to be swallowed by the sea millions of years ago, and yet it refuses to vanish entirely. Instead, it persists in a half-hidden state. Some see it as a cautionary tale. If tectonic forces can drown a continent to this extent, what else might be possible if plates keep shifting and reshaping the planet over geological timescales? When we look at Zealandia, we are not just peering at a curiosity. We might be staring at a potent example of how flexible the barrier can be between land and sea. Who knows how many landmasses of Earth's distant past now slumber beneath the ocean, quietly bearing witness to the planet's unstoppable cycles. The significance of this discovery goes far beyond bragging rights of adding an eighth continent to global maps. By studying the submerged layers of rock, geoscientists can glean precious details about climate change. Indeed, ocean drilling projects reveal how sediment layers built up over tens of millions of years, capturing chemical and biological signatures of bygone eras and storing them like pages in a library. Sift through these pages, and you will unveil patterns of ancient greenhouse episodes, mass extinctions, and fluctuations in sea levels. Such revelations are crucial because they illuminate how Earth's climate system works under conditions drastically different from our own. It is like traveling in a time machine, letting us see how the planet responded to environmental pressures we can scarcely imagine. With that knowledge, we can better predict how current and future climate shifts might unfold. Of particular interest is how plate boundaries, seismic activity, and volcanism all interplay to either lock certain gases deep within the crust or belch them into the atmosphere, driving climatic transformations. Zealandia thus becomes an invaluable laboratory for unearthing the system dynamics that have shaped life on Earth, from the primal soup billions of years ago to the modern tapestry of biodiversity. Of course, we cannot talk about a newly recognized continent without reveling in the excitement of potential breakthroughs that still await. This continent is a gargantuan puzzle with countless missing pieces. We have charted many parts of it, but huge regions remain virtually unexplored, waiting for the next generation of oceanographers and geoscientists to drop their instruments and see what secrets lie hidden in the depths. And it is not just about geology. Biologists, too, are keen to find out how evolution played out on this landmass while it was partially submerged, possibly providing insight into how marine and terrestrial species adapted to massive environmental upheaval. The bigger picture is that somewhere in these watery corridors lie answers to pressing global questions. How do continents separate and reform? What triggers major shifts in ocean currents that influence the entire planet's weather? How might deep tectonic processes factor into the future arrangement of our continents? The old adage that we know more about the moon than our own ocean floors seems all the more poignant when you realize how little we have scratched the surface of Zealandia. And if you are excited by all of this, consider subscribing to our channel. We have many more deep dives planned, and you would not want to miss the next chapter of this subaquatic detective story. At this point, you might be pondering how Zealandia's existence factors into the modern day. Think about the frequency of earthquakes that shake parts of New Zealand every year, or the volcanic rumblings that occasionally remind us of Earth's restless nature. All of these phenomena tie back to plate boundaries and the churn of tectonic processes. Because the boundary between the Pacific Plate and the Australian Plate cuts right across Zealandia, it is more prone to dynamic movements than other continents. On land, that can mean the disruption of human communities, roads, and infrastructure. At sea, it might signify the birth of underwater ridges or the unleashing of seismic hazards. Understanding these processes is crucial not just for local populations, but for the entire Pacific region, as seismic waves and oceanic shifts do not confine themselves neatly to national boundaries. The story of Zealandia is, in many ways, also the story of deep Earth interactions that reverberate across thousands of kilometers, connecting ecosystems, shaping climates, and even influencing marine life migration patterns. Knowing precisely how this hidden continent came to be, how it continues to evolve, and what future states it might shift into, is key to embracing the challenges of a planet that never stops changing. In essence, studying Zealandia is about putting together a puzzle that integrates everything from the fossil records of ancient plants and animals to the tectonic transformations that give birth to mountain chains' ocean floors. Scientists like Dr. Nick Mortimer, whose tireless dedication has helped compile decades' worth of data, represent a passionate community committed to shedding light on Earth's lesser-known chapters. Each dredged sample from the seafloor might contain microfossils that reveal entire epochs we never knew existed out here. Each measurement of seismic waves can confirm or upend theories of how continents are shaped. And each undersea drilling expedition can be the spark that leads to a bold new hypothesis linking oceanic currents and climate systems. This is the beauty of Earth's story. It is constantly unfolding, rewriting itself as new data emerges. For a long time, references to Zealandia might have seemed mythic or speculative, but as the evidence piled up, it forced a paradigm shift in how geologists classify continents. No longer is it enough to look for large swaths of above-water terrain. Now we acknowledge that the ocean can hide entire worlds from us, worlds that demand our respect and intrigue, lest we lose sight of the planet's full complexity. But let us not forget the everyday ramifications of all this knowledge. The better we understand continental boundaries, the more effectively we can prepare for seismic and volcanic hazards. When entire population centers like New Zealand stand perched atop a dynamic zone, pinpointing the region's geologic quirks can save lives through informed building codes, disaster planning, and public awareness. Meanwhile, the ocean resources locked beneath Zealandia's submarine shelves could be significant. Mining operations, fishing industries, and even tourism might revolve around this watery land. That potential, though, can be both a blessing and a curse, as exploitation of natural resources carries risks for fragile ecosystems already caught in a delicate balance. So, while we marvel at the idea of an underwater kingdom, we must also tread carefully, respecting the environment that has fostered countless species across geologic time. After all, the reason we can even stand on certain landmasses in this region is because of churning, unstoppable tectonic forces that do not exactly reflect human timelines. The more we peel back Zealandia's layers, the more we realize how intricately connected our planet's systems truly are. The interplay between plate tectonics, climate fluxes, and biology is evident once you start analyzing sediment cores from the plateau. Fossils can show us transitions from warm to cool climatic periods, or from shallow to deep marine conditions, each transition highlighting how Earth's climate repeatedly reorganizes. Such knowledge can inform how we interpret looming environmental shifts driven by modern factors like greenhouse gas emissions. If sea levels rose again by a significant margin, might more of Zealandia's highest peaks disappear beneath the ocean, or could tectonic uplift offset these changes? The answers require interdisciplinary research, bridging geology, geophysics, oceanography, climatology, and evolutionary biology. And that is precisely the thrill of it, standing on the cusp of knowledge as we dive deeper, literally and figuratively, into the hidden chapters of Earth's biography. Each time we turn a page in that watery ledger, we see reflections of our planet's cyclical transformations, reminding us that none of Earth's major shifts ever happen in total isolation. As we move forward, perhaps the greatest lingering question is why? Why did the Gondwana supercontinent break up so definitively, scattering large chunks hither and thither? Why are there so many extinct volcanoes across Zealandia, standing as silent sentinels of a more tumultuous era? In searching for these answers, we stand to uncover processes that shaped not just this region, but the entire globe. The rift that separated Zealandia from Gondwana was no minor event. It tied into the larger tectonic rearrangements that eventually gave us the world we recognize today. From the vantage point of deep time, we can see that subduction zones shift, mid-ocean ridges wander, and hotspots sculpt entire provinces. If ever there was a demonstration that Earth remains an ongoing experiment, Zealandia is it. We are living on a sphere characterized by unstoppable interior convection, forever recycling crust, forging and destroying mountain belts, and quietly rewriting the map when we are busy focusing on our daily routines. This unstoppable metamorphosis might well shape humanity's future in ways we have yet to foresee. Now, at this juncture, if you have been captivated by the labyrinth of stories that swirl around this underwater giant, do not forget to tap that like button. Your curiosity helps fuel our explorations, encouraging us to delve ever deeper into mysteries that could so easily remain hidden. From seismic secrets to the saga of how entire species adapted, or failed to adapt, to a continent that is largely submerged, there is much to glean from how Earth manages to keep writing fresh chapters. Each day, new technologies and research collaborations spring up, hinting at fresh breakthroughs on the horizon. Perhaps, in the coming years, we will map every subsea ridge, date every fossil discovery, and ultimately unravel hundreds of questions about how continents interact with global climate systems. Yet, one of the most enchanting things about exploration is that every answer typically leads to more questions. Thus, the saga of Zealandia is certain to keep geoscientists enthralled for generations to come. Thus far, we have seen that the continent's boundaries encompass a checkerboard of elevated submarine plateaus and basins, traces of supervolcanoes, and battered fragments of crust that have drifted for millions of years. All of this orchestrates how the ocean currents swirl in the southwestern Pacific, influencing local weather patterns and broader climates. We have seen that this watery realm was once part of Gondwana, boasting an ancient lineage that stakes a claim on Earth's primal heritage. We have recognized that it harbors an intricate record of earthquakes, volcanic activity, and glacial or interglacial phases captured in seafloor sediments. And crucially, we have come to understand that these hidden layers can answer the how and why behind critical transitions in Earth's climate. Even faint traces of plant pollens or the skeletons of marine microorganisms in core samples can be missing puzzle pieces that solve giant riddles about planetary evolution. So, what is the grand takeaway from all of this? In part, it is a sobering realization that even the basics we learn as children, like the number of continents, can be incomplete, shaped more by historical convention than absolute truth. In a way, this is a lesson in humility. Our planet is vast and ever-changing, and even with all our technology, we continue to stumble upon massive revelations. These revelations, in turn, shape how we think about Earth's past, present, and future. Zealandia reminds us that the ocean is still a frontier, a place where new countries of scientific knowledge can be found if we investigate thoroughly enough. The research is not just about understanding that a big chunk of land sank. It is about glimpsing how dynamic and resilient life can be, and how those same dynamic forces can shape the destiny of everything from local wildlife to the entire global climate. Imagine for a moment what the world might look like in another 50 million years. Could new collisions raise parts of Zealandia above water again, forging brand new landmasses or merging it with adjacent continents? We can only speculate, but the fact that these events are entirely possible should inspire both wonder and a healthy respect for Earth's power. The ground beneath our feet might seem stable, but we are living on a planet that is always forging new boundaries and erasing old ones, shaping the patterns of weather, life, and culture. If there is one lesson from the submerged realm of Zealandia, perhaps it is that seeing is not always believing. Our senses, after all, are limited, and there is more going on beneath the ocean's surface than we may ever realize. Yet, with each fresh drilling campaign, each new satellite pass, we chip away at the unknown. Bit by bit, we piece together a living tapestry, discovering how the planet has changed through colossal upheavals. The story of Zealandia is no longer a fringe hypothesis. It is a reality backed by robust data and recognized by respected institutions. So, as you carry this newfound knowledge, remember that Earth still holds countless secrets, waiting to be stumbled upon by intrepid explorers and curious minds. From time to time, you may wish to reflect on how quickly the puzzle of our planet can change. And if you are so inclined, consider sharing these stories with others, because it is in connecting the dots between continents, oceans, and climates that we truly begin to grasp the scale of Earth's intricacy and our own place within it. With that, dear viewers, we conclude our deep plunge into the waters of Zealandia, the youngest, smallest, thinnest, and perhaps most elusive of Earth's continents. We have explored its inconspicuous birth amid the breakup of Gondwana, its near-complete inundation as tectonic forces whittled away its surface, and its lingering mysteries etched into rock, sediment, and fossil remains. We have touched on how it reveals chapters of Earth's climatic and biological history, reminding us that the planet's story is still unfolding. Finally, we have gained a fresh appreciation for the planet's restless nature, as the unstoppable churn of plate tectonics continues to reshape continents, oceans, and the myriad forms of life they contain. This is not just about an eighth continent. It is about embracing the full tapestry of Earth science and recognizing that each new discovery reframes what we thought we knew. Thank you for joining this exploration. May these revelations spark awe and curiosity in your own journey to understand the planet we call home. After all, knowledge is the key to safeguarding our future and forging a deeper connection with the environment. Whether we are investigating the fate of the dinosaurs or predicting the next big earthquake, the threads always lead us back to the dynamic, ceaseless dance of Earth's crust. So keep asking questions, keep gazing into the uncharted corners of the map, and never forget, what seems settled can change in the blink of a geological eye.